imagine modern lifestyle. You get up with your favorite song from Spotify through the Google Home, and after breakfast, you go on the train or the bus, your phone starts buzzing. Twitter recommends you the news you want to miss. LinkedIn recommends you people you may want to know. Then you start read some news, BBC or Hacker News recommend the news in the day in the field you're actually interested in. Then finally, you sit down in front of desk doing something important. You open Google or Stack Overflow to do some checking, and the system recommends you the most rated topic according to your searching criteria. Then you realize your daughter or wife's birthday coming, so you go to Orleans or Kicks to find most trendy product or most classic perfume as the best gift. And your business trip is coming. You had to book accommodation and tickets. You open scanner or booking.com to find the most feasible solution as you can. It's dinner time. You want to find the most popular recipe in town in the season, so you go to Willis or a ham shop. They, according to this best recipe, according to your purchase brand preference, recommend you the raw material and send to home. Maybe you also want to buy a glass of red wine. You use Vivino or Cinsault to get your favorite one from France. In the evening, you sit down yourself in the sofa and Netflix or Apple TV recommend you the movie, the most recent movie or the movie you want to see. According to Cornell University researchers, people make around 35,000 conscious decisions per day. And only for food, we make around 224. And it's a lot. So every day, every well recommendation system actually make our life more effective, more efficient, happier, and maybe biased. My name is Celine Xu. I come from Axel Johnson, work as a senior data scientist. Today, my topic is how to build an in-house recommendation system. Hope our experience can inspire you and your team for your future work. I want to cover two topics. First, the definition of the recommendation system from my perspective, and how to build a prototype in 6 weeks. Lesson learned. Let's get started. The definition of the recommendation engine or recommendation system varies from Google, Wikipedia, or Microsoft. But for me, it's just one sentence. It's an automated predictive scoring system based on the historical record. And it's connect 2 words together. One is product, the other is customer. So this definition have threefold. The first one, technically, is just a predictive scoring system. So what this means is you can use a simple skill as segmentation, as complex as matrix factualization or neural network to do this predictive tasking. But you still need to have an, holistic scoring framework backward. And when you have this system automated in large scale, you start to realize the real business value. Cut the human cost for detailize each campaign and make more relevant recommendation. And also, this system has some limitation based on its processing data, historical or near historical. And take collaborative filtering as example, the famous co-start problem, which is it's hard to recommend something really new, not have ever purchased to the customer. And also the reach-to-reacher problem, which is the most popular product still be recommended the most. At the same time, at the end, I would say this system always biased, but it's really hard to say which bias is good or wrong. Take example like this. If you have a membership base, have 90% of the member are female, then when you actually want to recommend things to the male, you got female record to bias the recommendation. However, if you want to solve this problem to tag the product as man product or women product, you introduce another kind of bias in the system. But there's no right and wrong answer, and someone said the machine never right, but some machines are useful, and depend on the business logic, you will have your own. Okay, the good news here is we can build a prototype in 6 weeks with no prerequisition of the infrastructure, and you can use any programming language you want. Personally, we used R, SQL, Python, Scala, PySpark, and we recommend you use simple machine learning model at the beginning, which is memory-based collaborative filtering as a core. I also want to add a little bit more restriction for this statement. You have to have a holistic product hierarchy and certain level of customer segmentation information, because we don't have time to do content-based machine learning, which is natural language processing, to tagging. But with transaction data, we're ready to go, if we have right expectation and the right process. Let's talk about expectation first. 3 initial questions you need to ask yourself. First, why you want an in-house recommendations system at the beginning? Why not just buy one? Second, how you actually want to use this machine to actually generate the business value you promised? And third, how you evaluate this system, and what's the definition of the good enough from your perspective? We have some understanding to share. So for the first question, we were saying the advantage of in-house recommendation system is it's tailored. How is it tailored? Which means you can embed your business logic within the system and also put on your business priority in the scoring system. At the same time, this is a living system, which means you can constantly twist, change business logic, and keep develop it. And last but not least, it's an exploring system, help you to actually understand your customer behavior. When you twist different parameter, you receive the response. And then you know how you twist it in the future, how the customer could respond. And the second question, I would say the hardest part to build the recommendation system is not build the engine itself. It's actually convince your internal business user actually use this system to build on the trust and to change their way of working. And only when they change their way of working to use this tool you're building to facilitate their daily work, they will generate the business value. And last one, we will have and dedicate slides to talk about how we evaluate the performance of the recommendation system. But here, I just want to say, be realistic. One question here, on a scale of 1 to 10, how will you evaluate the recommendation you get from Netflix, from Spotify, from Zalando? And please keep that number in mind. And those companies have more than 200 data scientists and work for the recommendation engine or recommendation engines for years, and you got this result. So when you get your product from your data scientist after 6 weeks, please be realistic, be gentle. And in this way, you will have more engaging, positive base and build on. So let's talk about process. I have 5 key success elements to share. First, it's just a scoring system, so everyone can build it. What this means is you have to focus on scoring part first to build the model to predict the score for affinity, and then to build a business sort of framework to balance various of business perspective as the final scoring table, and start small. What we mean start small is use transaction data at the beginning as only one resource to test this model, whether or not it works. And then maybe you can add abandoned basket, add the website viewing data from this, and it will generate business value, easy to generate business value or test whether or not it works. Second, I want to emphasize how to translate the business rule into this recommendation system and how to translate that into the parameter in the recommendation engine is more crucial than you actually choosing either of the algorithm. What I mean business rule here is business logic, business domain knowledge, the threshold. Take beauty and fashion as the example. If you recommend beauty product, which we say lipsticks, you probably want to recommend customer who they already buy and repeatedly buying things. But for fashion, I don't think that is a good idea to recommend something they already bought. The thing is, they may have a high affinity to the brand they buy, and they probably have a high affinity to cross product category, what they buy. And the third one is, when you evaluate this recommendation system, it's not always about accuracy. You want to build a system to understand the customer behavior, at the same time balance various of the business perspective and statistically choose a best choice. And the best is not equal to the accurate. Number 4 is a little bit cliche, but it's actually the real truth. Cross-function team and change the way of working will finally realize the value creation. What we call the cross-function team here is we will have a core team, have at least 4 roles, data scientist. There is a word says data scientist is built to learn, so give them more time to explore, to understand the parameter, to try different algorithms. And then data engineer come in. Data engineer is learn to build, which they will streamline the process, make the code more maintenance, add the error tolerance to the system to build up a continuous integration platform. And then you still need to have a business analyst in the team, talk to the data scientist to test the business domain knowledge, to verify the hypothesis, to verify the feature, whether or not it actually represent their thinking about the business rules. And then you also need a person from data or database team to guarantee the data source. And as we mentioned, fundamentally, how this machine will create value is when the people actually use them. So how you engage them is crucial. There is the effect called IKEA effect, which means if you involved the person in the early age building the product, they are more likely to like this, have more trust, and have the way to use them. Fifth, continuous end-to-end testing will generate real insights. We want to highlight end-to-end testing here because it's not only about model and it's not only about accuracy. And only when you actually send out the recommendation and get feedback from the customer or see any financial KPI improved, you will find whether or not this machine works or not. And also, there is a way to actually make this testing more smooth. So I think there are at least 3 stages of testing. First is pre-sending out testing, which you actually evaluate your model accuracy and some business KPI, like average recommendation profit margin or average coverage of the product. And then you have a friend and family group, and you can actually send out to test integration of the campaign system, whether or not link work or not, how is the template look like. If everything good and you actually also take some feedback from them, twist the weight of the recommendation engine. And then you have a dedicated A/B testing for your target group, and then you receive the third level of sort of testing result, and then go back to your model to continue to build on. Then now allow me to go into a little bit detail for each of the statement. First, I want to show you how the data flow, the table format, is actually flow within this scoring system. What I want to mention here is like we were choosing the collaborative filtering as the example. So fundamentally, we will create this customer basket metric, which have each column the one product and each line of a customer. But here you have to have two questions in your mind. First, fundamentally, what kind of recommendation you want to recommend? Take grocery as the example. Whether or not you want to recommend product called la strawberry flavor yogurt 205 millimeter, or you actually want to take flavor away to recommend only la yogurt. The first thing you want to understand. Second thing is, when you understand which level of the recommendation you want to give, what score level you want to give for this recommendation. For example, still take yogurt as the example. So maybe you will not want to calculate affinity score based on each customer and each yogurt, but you want to have each customer for la yogurt, and maybe what I mean is like you can decipher this product into at least two dimensions. One is brand dimension, and you can calculate brand affinity. And then on the product hierarchy dimension, you can find a level which you have enough product category, but not so much product category. And then you can feed this data in the training machine, and you will have item-to-item based score. And then you use training machine, feed in the predictive data, and you will get customer brand or customer item based score. And then you have to prepare, we call it pre-scoring table, which we have each target customer who actually bought the product with each available product as cross-join. And then we feed everything together, look at if we have multiple model, as I mentioned, we have a brand model and product model, maybe function model, maybe color model, and we have each score, and we'll prepare this holistic, we call it final scoring table, and then we add weight to each predictive score we get from each model, and we got the combined score, and then we rank based on the combined model. After the scoring, we still need to think about filtering. And let me zoom in a little bit for this, how to prepare this pre-scoring table. As I mentioned, we have recommendation system connecting two words. One is product, the other is customer. So for product side, I would say the most important thing is you have to think about the filtering. You get the data from transaction. You have to think about whether or not they're in stock. And also, there's some sensitive product, especially for medical or beauty. Sometimes it's kind of embarrassing product, and you need to filter it out, and you create this product pool, we call it. And then, from customer side, the first task is we need to separate customer, who bought the product in a certain defined period. The other is the customer doesn't bought. And for the customer who actually bought the product, we use this cross-join to prepare this final scoring table, because the machine can only output the score when this customer have any kind of purchasing history. If the customer is new or doesn't have purchase history, it doesn't work. Then we have to use some old-fashioned skills, which is segmentation, and then we use segmentation-wise ranking to fill in this gap. One trick here is if you have better segmentation and better logic within segmentation to do the recommendation, you can actually improve that part of the scoring. And then allow us to zoom out a little bit to see the whole flow. We have the data source first. We have first stream, we call it training stream, which will not be updated every time. It will be like stabilized for a time of period, for example, 3 months. At the same time, when we train this data, prepare this data, we need to choose a certain time period to have this training data. Maybe 1 year is good instead of 3 months to actually see how this customer affinity with a certain brand. And then we need to prepare this basket again, but not use 1 year data, maybe use 3 months data because you want more recent behavior or you want to rule out the product you don't have anymore. So you use 3 months data, and then you feed in and use the machine you train, you get the score, and then you put in the final scoring table, as I mentioned, and then you send out, and you get your validation. And then it's an iteration process. And every time you receive new response, you go back to the old score table to twist the waist to see the response. Or sometimes you actually need to go back to your model to add one more model. For example, we had this problem with reach-to-reacher problem. We don't have enough coverage. For example, we have maybe 20,000 products available to recommend. But at end, the recommendation system only recommend 3,000. And for most of customers, we recommend 50% of repetitive product at the beginning. Then finally, we actually add one more model to solve this issue. My point here is this is the iteration problem, and sometimes you can't predict the result, and you can't know where the problem will have. If you keep doing this, it will actually leverage the in-house system instead of purchasing, because if you purchase and recommendation system is more like a black box and you're out of control, it's hard to twist and improve. Since today is the machine learning summit, I think the following 2 slides will represent my understanding about the algorithm within the recommendation system world. So fundamentally, I think there's 3 streams of the, and this also answers some question I got initially from my product owner, why I choose collaborative filtering, why not something else, and how they collaborate each other, how could we combine them together. So fundamentally, I would say there's 3 streams. One is pure from customer perspective. We call it actually segmentation. So this answers the question. No matter what this customer bought, if they belong to a certain group, we will recommend them the same product. And the second one, we call it associate rule, which we also can call it basket analysis. It's pure from product perspective, which means no matter this customer is, if they buy item A, B, it's more likely they will buy C. And the third one is most widely used cluster category, which we call it collaborative filtering, which combine both customer perspective and product perspective. And it has 2 streams. If we talk about customer-based collaborative filtering first, 1 sentence can describe that. So you will buy something, people like you, what they bought. And the other one is called item-based collaborative filtering, which means if you buy product A and B, you more likely buy product C because of product A. Empirically, the item-based collaborative filtering is slightly performing better than the customer-based collaborative filtering because the product size have more objective or stable features. And now let us zoom in a little bit from collaborative filtering world. So there are 3 main streams. One is called content-based collaborative filtering, the other is memory-based, the third one is model-based. But fundamentally, it's in the middle. So everything is based on the memory-based collaborative filtering. And when you don't have an holistic product hierarchy, you go to content-based, which you use natural language processing to do tagging, calculating, and you actually build a matrix like purchase basket matrix. You have each customer as each line, and each content is each column. Fundamentally, they're the same. And when you want to improve the performance of the memory-based collaborative filtering, you actually go to the model-based. And if you want to shrink the customer or you want to shrink the number of rows, you do clustering first to make the customer into different clustering. In able to calculate customer to item affinity, you calculate the customer group to item affinity. And the other way is matrix factorization, which you actually use embedding technique to to find eigenvector for this sparse matrix. And then if you don't use embedding, the other way is you actually feed the whole transaction matrix into the neural network, use activate function and different layer to actually find that the score. And then, as we said, business rule and parameter is more crucial in the system. So I think there are 6 different business rules. Since we already drilled down into one of them, which is business logic and how we confirm define the basket, we go on the other one. One is how you actually design the final scoring matrix. So if we calculate the affinity score on high level of product hierarchy and brand, we still have the gap from the product itself to the customer. How you make the gap, whether or not you add the total volume within the customer segmentation, or the profit margin, or the volume, or you need to actually add some balance because some of the product group have more product. Say, if you use lipstick as an example, you probably have 20 products because they have different color. But if you have eye cream from a certain brand, maybe you only have 1. But if you use collaborative filtering on both products, the score will bias or favor the product actually have more product within that product group. Then whether or not you will add an extra balance for their scoring is crucial. And then we have this filter for pre-filter the customer. Maybe you need to think about whether or not you want to exclude those transactions which the customer only buy only one kind of product to make the connection between the brand or product more balanced. And after product filtering, which I mean, you want to take out something the customer buy the last time, maybe within 2 weeks. And also, whether or not you want to enable your recommendation engine have more variety of recommendation for each customer. For example, limited the number of product within each brand to recommend, or each product category to brand. And also, based on your evaluation business rule, you will have evaluation parameter. And the other parameter is actually standalone, which not really within the business rule field, which we call it a statistic metric. They have 3 of them. One is how you actually define your basket. Whether or not you use binary score, or you actually use the volume, or you actually use some other things, which is continuous number. And different choice will have different sensitivity for ranking. And second thing is, after you have each predict score for each model, you want to have this final scoring table, how you normalize those scores before you have the combined score. Whether or not you just use log transformation, make it more normal distributed, or you want to normalize within the whole customer group, or you're actually parsing it by each customer. For example, you have different score for the brand for each customer, you only normalize it with the range for each customer. And you got different sensitivity of the final scoring table. Finally, we talk about evaluation. And accuracy is not everything, but it's still important. 3 methods you can evaluate this accuracy. Either you do train, test, split to train your data, or you actually measure the recommendation with the basket they already bought, or you actually have the recommendation and you send out, you're collecting the information backward, and you calculate either the root mean square error if you're doing scoring-based system, or you're doing confusion metric statistic if you're doing classification. But it's not all. We still need to have the other things, like we want to nudge people to buy something they don't even know, so we call it novelty. And we want diversity of recommendation. And also, we want to test how our recommendation engine able to recommend something. So the percentage of the recommendation engine recommend compared total available product is also important. It's also showing how recommendation engine is better than people to actually make a lot of low-frequency sale product more available to our customer base. Not but least, we still have this financial perspective. This financial perspective will have overall level and per customer level. For example, how many customers you actually recommend for each customer, how many recommendations you have, and what is the average margin for your recommendation. And this is kind of crucial if you want to have this upsell. How you define upsell? Maybe you actually calculate the recommendation profit margin and compare to currently how customer bought the average margin, and then you only choose the one actually over that one. So this kind of KPI also important, and more importantly, it will convince finally the business holder how you achieve your business goal. Last and not least, we have our way of working. 3 technical, we want to sort of state here to help us to engage our internal customer are daily stand-up. We split our audience into key team member and stakeholder, and daily stand-up is for the key team member. It's a really good way to identify early hinders and solve hinders and just to stay what they want to do within the week. And then we have this bi-weekly presentation, which we will engage our stakeholder, and we are internal user of the system to let them give our feedback, early change to build up the trust. And then we will visualize the work stream. It will look like this. It's simple. You can use Trello board, like whiteboard, whatever. You will have sprint, you will have stopper, you will have what done, you have the backlog, and you have different stream based on different key members. And you will have task with the name for each task. And you can move around a little bit if everyone agree. In summary, I have 5 sentences to let people remember for this talk. First, recommendation engine is just a predictive system. So you can do it, but they have limitation. Try memory-based collaborative filtering first, and start small. Second, business rule is more important than actually choose an algorithm. So anchor an algorithm and then build up on. Building a balanced performance evaluation metric is really important to actually test the performance of a recommendation engine. It's not always about accuracy. Cross-functional team and new way of working is fundamentally generate the business value. Finally, continuous end-to-end testing is important, and please start to day 1. Thank you, and any questions?